Hello and welcome to the introduction of Texas Instruments' new reference design for leakage current measurement for determining insulation resistance. This new TI design TIDA-00440 provides a solution to measure the insulation resistance up to 100 megohms with an uncalibrated accuracy of 5%. Applications include all electrical equipment where maintaining isolation insulation is critical, such as power supplies, motor drives, high voltage transformers, and solar inverters. This reference design uses a mechanism to find leakage current and detect the failure in insulation using two boards. The main board, which is the signal conditioning circuit, and the daughter board, which has an isolated 500 volts DC supply. The test and insulation parameters are derived from the IEEE standard IEEE 43-2000. The block diagram for this design shows that the leakage current is measured by applying a fixed voltage and measuring the voltage across a shunt resistor that is a result of the leakage current. The reference design uses different switchable shunt resistances, which are switched on in a sequence to measure the insulation resistance. When there is a dead short, the insulation resistance is 0 ohms, and a maximum current can pass through the insulation. At this point in the measurement, having a smaller shunt value is mandatory with a multiple shunt approach. When the insulation is higher, a larger shunt value is required with a single shunt approach. The leakage current flowing through the shunt or shunts is measured using an integrated current shunt monitor, the INA-225. The leakage current is amplified with different gains, which can be programmed using pins GS0 and GS1 of the INA-225. If using the gain of the INA-225 is not required, the voltage across the shunt can be routed directly by using an onboard multiplexer, such as the TS5A23157. The measured output voltage is isolated and available to the MCU's integrated ADC using the AMC1200 isolated amplifier. The switchable shunts and the multiplexer channels are controlled through dip switches, which are isolated using the ISO 7640 FM digital isolator. The switchable shunts and the multiplexer channels are controlled through dip switches, which are isolated using the ISO 7640 FM digital isolator. The dip switches are used to emulate the signals coming from the MCU to change the gain in shunts. The board operates from 15 volts and then generates two isolated 5-volt rails with a fly-buck topology using the LM5160 fly-buck converter. The daughter board consists of an isolated discontinuous mode flyback circuit for generating 500 volts DC from an input voltage ranging from 150 volts DC to 800 volts DC. This is the PCB of TIDA-00440. There are two terminals for the high voltage DC input to the daughter board. The board generates a regulated 500 volts DC for the measurement purpose. These two terminals connect to the equipment whose insulation needs to be measured. The onboard relay is used to switch between the calibration resistor and the insulation resistance. These are the isolated measurement circuits using INA-225 and AMC1200. The board is powered using flybuck power supply. These are the accuracy graphs for this TI design. With the multiple shunt approach, the value of shunt resistor is changed on the fly by switching on and off the MOSFETs. For single shunt approach, the shunt resistor value is 22 ohms, and the gain of INA-225 is changed when required. It can be observed from the accuracy graphs that multiple shunt approach has better accuracy compared to the single shunt approach. For more information about this design and to download the schematic, bill of materials, user guide, and design files, please go to ti.com/440. Thank you for your interest in TI designs from Texas Instruments.